Computer-aided design has revolutionized operations management, providing numerous advantages but also presenting some challenges. CAD plays a critical role in industries that require precision, speed, and collaboration in design processes, enabling companies to streamline their workflows and improve the quality of their products. However, along with the significant benefits, there are drawbacks related to cost, complexity, and potential over-reliance on technology. Let's start with an in-depth analysis of the advantages of CAD in operations management, with real-world examples to illustrate its impact. One of the primary advantages of CAD is its ability to improve design quality and accuracy. By allowing designers to create precise 2D and 3D models, CAD minimizes the risk of human error and ensures that products meet exact specifications. For instance, Tesla uses CAD to design intricate components for its electric vehicles, such as battery systems, where precision is crucial for both performance and safety. This capability not only enhances the quality of the final product, but also ensures that components integrate seamlessly with the overall design, reducing the likelihood of errors during production. In addition to improving accuracy, CAD speeds up the design and development process. The software allows engineers and designers to create, modify, and test designs quickly, which shortens the product development cycle. Ford Motor Company, for example, utilizes CAD to design new car models more efficiently. By enabling rapid iteration of designs, Ford reduces the time to market for new vehicles, giving the company a competitive advantage in the fast-paced automotive industry. Cost savings are another significant benefit of CAD. By using virtual simulations and tests, companies can minimize the need for physical prototypes, which reduces material waste and lowers development costs. Airbus is a leader in aerospace engineering, employs CAD to simulate the performance of aircraft components like wings and fuselages before production. This process significantly reduces the cost of physical testing and prototyping, making CAD a cost-effective solution for complex industries like aviation. CAD's flexibility also allows for easy modifications. Engineers can quickly adjust designs without starting from scratch, and customized products can be developed with ease. Nike uses CAD to design personalized footwear, tailoring products to individual customer preferences. This flexibility not only meets consumer demand for customized products but also streamlines the production process, making it easier for companies like Nike to adapt to market trends. Collaboration is greatly enhanced through CAD as well. Design teams, often located in different parts of the world, can work on the same project in real time, facilitating seamless communication. Apple, for example, uses CAD to enable collaboration between its design teams in Cupertino and manufacturing teams in China. This capability helps Apple ensure that product designs align perfectly with manufacturing requirements, reducing errors and speeding up production timelines. Moreover, CAD allows companies to conduct virtual testing and simulations, reducing the need for multiple physical prototypes. General Electric uses CAD to simulate how jet engine components will perform under various stress conditions. This enables GE to improve safety and functionality while reducing the number of physical tests required, ultimately enhancing the overall design process. Despite these advantages, CAD also presents challenges. Let's focus on the disadvantages of CAD. One significant drawback is the high initial cost of implementation. The software, hardware, and training needed to use CAD can be expensive, particularly for smaller companies. Tesla, for example, invested heavily in CAD infrastructure to design its electric vehicles, a cost that might be prohibitive for smaller automotive manufacturers. Although CAD ultimately reduces costs in the long term, the upfront investment can be a barrier for businesses with limited resources. The complexity of CAD software also means there is a steep learning curve. Engineers and designers must undergo extensive training to become proficient in using the software, which can lead to initial delays in operations. At Ford Motor Company, engineers spend significant time learning advanced CAD tools to develop new vehicle models. This training adds to operational costs and can slow down production in the short term. Another risk is the over-reliance on CAD technology. While CAD simplifies the design process, it can also lead to a loss of manual design skills and creativity. Architectural firms, for example, may find that their designers rely too heavily on CAD templates and predefined workflows, potentially stifling creativity and innovation. This dependency can also become problematic if the software crashes or becomes outdated, leading to disruptions in operations. Data loss and security concerns are additional disadvantages of CAD. Since CAD files are stored digitally, they are vulnerable to cyber attacks, system failures, or unauthorized access. For instance, a hacking incident at an automotive company could lead to the theft of proprietary designs, giving competitors an unfair advantage. Companies must invest in robust cybersecurity measures to protect their CAD files, which adds to the operational costs. Moreover, CAD systems require regular updates and maintenance, which can result in downtime and additional costs. For example, companies using AutoCAD must frequently upgrade their software to remain compatible with the latest technologies, which can interrupt ongoing projects. This need for continuous technical support and updates can disrupt workflows and lead to increased operational expenses. Lastly, while CAD streamlines the design process, it can also lead to standardization that limits creativity. Designers may become constrained by the tools and options available in the software, relying on predefined templates instead of exploring innovative design solutions. Architectural firms, for instance, may find that while CAD speeds up drafting and modeling, it can limit the development of unique. In conclusion, computer-aided design offers significant advantages in operations management, from improving accuracy and speed to facilitating collaboration and reducing costs. Companies like Tesla, Airbus, Ford, and Apple demonstrate the transformative power of CAD in their respective industries. However, these advantages must be balanced with the challenges of high initial costs, complexity, potential over-reliance, and cybersecurity risks. While CAD can drive innovation and efficiency, businesses need to adopt a balanced approach to maximize its benefits while mitigating its disadvantages.